Okay, let's get right to work on this here. Um, this is, for many of you, a very important lecture. So let's take our time here. It's 5:26. This is video 102. And let's look at the title here. It says GCF, and you probably know, or you should know, that that means the greatest common factor, factoring by a monomial. So remember, a monomial is one term. And I put an easy problem up here, a sixth grade problem. It's amazing how sixth grade keeps coming back to haunt us when we do high school math, even eighth grade math. And I take a look at this, and we call this a numeric expression. 24 plus 16. The sum is 40, but no one asked you that. It's just a numeric expression. There's no algebra in it, no x, no a, no b. And so what I'm going to do is I'm going to factor it two ways, and we're going to give everything a name, and then we're going to substitute the polynomial or the algebraic expression math that we're studying now. So what's another way to write this? Well, I put this into parentheses, and you probably learned that I can extract a 4, and 4 times 6 is 24, plus 14, and that obviously works because according to PEMDAS, 6 plus 4 is 10, and 10 times 4 is 40, just like the one above. But this is factored, but we're going to introduce another word here. It's not completely factored, and that's going to be really important for us as we go ahead. There's another GCF, another factor called the GCF, which works much better, and that's the biggest number that 24 and 16 share. So that's 8. How do you find the GCF? Well, they taught you different ways in 6th grade. In high school, they generally give you easy numbers, so it's not a big deal finding it. However, I'll show you methods to find the GCF as well. There are quite a few. And let's check this one right here. 3 times 2 is 5 times 8 is 40. So it's equivalent. And this 8 here is called the GCF. Okay? And it's a monomial. It's going to turn into be a monomial. Okay? In this case, x to the 0, but we won't get into that. And now a really important word. We say that this last expression, here's the first one, here's the second one, here's the third one, is completely factored. And you should keep this in your head. Very important word here. This is completely factored. Very similar to prime factorization. Okay? And this is what interests us in high school. Okay? So there we go. A numeric expression, I factored it once, but it wasn't completely factored. That's all we're really interested in. But in the second case, I factored it out completely. How do I know I can factor it out completely? Well, there are a bunch of ways, but the one that's most important for us is the numbers that are left over. I'm going to use that word. The real math word would be residual. I'll write that over. Leftovers, like the food you didn't finish that you put back in the refrigerator. Okay, or 2 terms. If there's 1 term, there's nothing to talk about. How can you factor 1 term? It's 2 or more terms. We will factor up to 3, even 4 terms, but that doesn't turn out to be a problem. The leftovers, and some people call them residuals, the math people do. The leftovers, okay? All right? And these are the numbers that I couldn't extract from here. And like I said, I checked myself to get it right. And when these two numbers, are you ready? Again, a word that I've used quite a bit, are coprime. The residuals, the leftovers are coprime, then you know that you factored it out correctly. Or, to use the word that we use in math, completely. Okay? So now, once I find the GCF, and they probably taught you in 6th grade, then you immediately know the LCM, because it's the GCF times the residuals. So that's 8 times 3 times 2. So the LCM is 48. One more time, the residuals are coprime. That means only one divides both of them. That's the only factor that they share, talking 6th grade math now, and then I multiply it times the GCF, and then we see it one more time, 8 times 3 times 2, which is 48. I ignore the plus because I'm just finding, since I know the GCF, I'm finding the LCM. So I hope you're paying attention to what I just did. I took over 5 minutes to explain my 6th grade math thing here. And now I'm going to do the same thing again, but I'm going to turn it into the math that we study now. So I'll quickly erase this stuff. And I'll only do this, and I'll follow everything up with more lectures and certainly lots of practice. And remember, one more time, when we talk about a GCF, the greatest common factor, the Regents is not a number theory class. They're not going to give you hard ones to do, just easy ones. And I'll teach you methods for finding them. Now let's take a look at another guy here. And now, instead of being 24 plus 16, now it's an algebraic expression. If we're using polynomial talk, it's a binomial quadratic, or a binomial degree 2. And now I'm going to factor this out a second time and completely factor it. So this factors, but it's not completely factored. This factors, but it's not completely factored. So what completely factors it? Oh, and you should check this out. We know how to multiply them now. So this is just a binomial times a monomial. We did that correctly. I found the numerical GCF. And what's the greatest common factor of x squared and x? Well, x will check our math the way we know how to do. And you go back from here to here. So these are factored. No question about it. They've been factored. But only this is what? Completely factored. And you should be thinking about what I'm saying, because this is going to come back big time, no matter who your math teacher is next year. Okay? So there we are, a little bit of 6th grade math turning into a little bit of freshman math. And now I'll show you methods to do this, but let's make sure that we're identifying everything. This monomial here is the GCF. And what's the LCM? Well, 3x and 2 are coprime. What do I mean by that? They don't share anything, only the 1. Okay? So that means that this is correctly. Here they share the x. Here they share a 2 that turns into the 8. So what's the LCM here? Well, it's 8x times 3x times 2. So it's 48x squared. And I'm going to follow up these ideas down the road. There's your LCM. And the basic thing that you should see here is you can treat polynomials, algebraic expressions, they turn out to be equivalent, just like numbers. Just the same exact ideas come up, numbers. And what I just did, by extracting the 8x, which is the biggest number and the highest x that everything shares, is I factored this. And here I factored it incompletely, but in the last corner, what I did over here on the last line is I factored it completely, and that's what we're looking for when we do math. Okay? And just like I found the LCM of 24 and 16, I also found the LCM of 24x squared and 16x, and we can double check ourselves, and then I'll end the lecture. 48x squared divided by 24x squared, and this is where we're heading, by the way, we'll be doing this pretty soon, equals 2. So I check that off. Draw an arrow there so you can see what I'm doing. And then I multiply the other one, I divide the other one 48 squared, 48x squared. You can see this, right? We'll make it a little lower. 48x squared divided by 16x, that's the second term. Okay, there's the first term dividing the LCM. There's the second term dividing the LCM, equals 3x. But again, that matches this perfectly. And there we go. We found the LCM. We defined coprime. And we see that these algebraic expressions, these polynomials, work the same exact way as numbers do. And they're just sort of abstract substitutions for numbers. So I'm going to leave this here. You can see it for a second. And we'll have this for you. There's the date again, and there's the work that I did, and I'll definitely repeat myself, and you'll be expected to factor by a monomial, okay? And the monomial factor is called the GCF. You easily find the LCM. You can check the LCM and get back to what you did here, and then we pointed out to you that this example and this example are factored, but they're not completely factored. So we'll leave it like that, and we'll follow this up.